We're going to look at the example on page 12 of the notes. So let me erase this here really quick. All right, so the example reads, suppose that the number of seconds it takes a person to unlock their phone X is uniformly distributed on the interval 0 to 6. Below is the density curve. All right, so let's kind of look at what this density curve is telling us. Notice along the x-axis here we have 0 to 6, so this is really 0 to 6 in seconds. And the first question asks, what is the width of the density curve? In other words, we're asking for what is this distance here. So there's two facts we can use to help us do this. The first one is that the area of any density curve is equal to 1. And then also we know that the width times the length of a rectangle is equal to the area. Well, we know the length of this density curve because it runs from 0 to 6, so the length is 6. And then we know that the area is equal to 1. So solving here, we have that the width is equal to 1/6. Next question asks, what is the probability that unlocking the phone takes more than 5 seconds? So looking here, I'm just going to mark where the center of the box is to help me. So the center is at 3. And I want to know what the probability that unlocking the phone takes more than 5 seconds. So we got 4, 5. So really when we talk about probabilities, that's the same thing as the area under the curve. So in this case, it would be the same thing as this area right here. Well, notice that the width of this shaded rectangle is 1/6 because it's the same as the overall, but the length for this one is going to be equal to 1 because it's the distance from 5 to 6. So this tells me the probability that x is greater than 5 is equal to 1/6 times 1, which is equal to 1/6. Let's try the next one. So the next one says, what is the probability that unlocking the phone takes less than 2 seconds? Well, again, I'm going to mark 2 seconds here, and the probability is the same thing as the area under the curve. So I want the probability that x is less than 2. Well, again, the width here is still 1/6, but notice now the length runs from 0 to 2, so my length is 2. So times 2 is equal to 2 divided by 6, which is equal to 1/6. Right? So the next question says, what is the probability that unlocking the phone takes between 3.2 and 5.7 seconds? So I'm going to come down here. Again, the midpoint occurs at about 3. So we'll say 3.2 is here and 5.7 is here. So to find that probability, I'm looking at the area of this box. So again, the height, or probably not the height, but the width is 1/6. But now the length of this box runs from 3.2 to 5.7, so that is 2.5. So the probability that x is between 3.2 and 5.7. So what that's saying is that x is greater than 3.2, but less than 5.7. So the width here is going to be 1/6, and then the length is 2.5. So then you could put that in your calculator, and you should find that that is 0.4167. Oops, wrote that on the wrong line. And so writing this, I realized that there is a typo. This 8 right here in the solutions should be a 6. So change that, and then that will change this decimal right here. And I will fix those in the notes on Blackboard. All right, so what is the probability that unlocking the phone takes exactly 6.5 seconds? So let's erase our work from the previous one. All right, so what we're asking here is the probability that x is equal to 6.5. Well, notice that our sample space runs from 0 to 6, and it's any number including or in between 0 and 6. 6.5 is not in our sample space. It's not an option for the random variable. So automatically we know that this is equal to 6. Or probably equal to 0, not 6. What if instead we had asked for the probability that x is equal to 3? Well, again, I could come up here and draw 3, but remember that the probability is the same thing as the area under the curve. So that would be the same as asking how much area is directly above the number 3. Well, it ends up that that area is equal to 0, because you could continually draw a thinner and thinner line above 3, and so really above any individual number, the area is equal to 0 for a continuous density curve. Now notice for each of the problems up above, we weren't looking at an individual number. Instead, we were looking really at intervals of numbers. So here, any number greater than 5, any number less than 2, and any number between 3.2 and 5.7. Now, since the probability of being exactly equal to a number is 0, we could have also written all of these like this. We could have included the equal, and it would have made no difference. So for continuous probability distributions, we don't have to worry about the equal sign. Whereas with discrete probability, it does make a big difference.